Hey everybody, welcome back. I'm Deez, this is my workshop. I'm going to do a quick intro to this video. It'll probably be a short series of videos, but today we're going to explore model engines. Recently, I've made acquaintances with Aaron Kohler, part of an engine club up near Fort Wayne, Auburn, Indiana, northern Indiana. And, you know, there's a whole world of model engine making, and that's a hobby in and of itself. I'm not sure how deep I'll get into model engine making. It's fascinating. It's a bigger world than I thought it was. Started doing some reading and some research into it. It's very interesting. But what I really love about it is the opportunity to make parts to make a functional, tangible product in the end. It lets me use the machines. That's really what these workshops about, is using these machines for hobby machining and not just model engine making. So this isn't going to be a model engine channel, but I do want to get into that, and I'm going to tackle a very simple model engine. It's the N.A.M.E.S finger engine. What is N.A.M.E.S, you might ask yourself? It's the North American Model Engine Society, and they have these plans. I'm sure they have all kinds of plans, but they have plans, or at least the plans for this finger engine are provided from them. They have a website. I'll try to post some links in the description that might point you in the right direction if you're interested in making one of these. But there's somebody rewrote the plans into a little bit more detail, and these are the kind of the original ones from North American Model Engine Society group. Just a single sheet with some specs. The really cool thing, as I progress through this, the really cool thing is you can actually take some liberties into designing and creating your parts. It's pretty interesting. I'm enjoying it so far. So this will be a multi-part series. It is taking me a while to wrap my head around things and get some of the parts created. I was also fortunate enough to make it up to the Indiana Model Engine Show in Auburn, Indiana at the National Auto and Truck Museum. It was a really fascinating event. There's some impressive machines up there. A lot of great folks. If you ever get a chance to go to a model engine show, find one in your area and check them out. A lot of hit and miss engines, Sterling engines. Some of the engines are designed and created by the hobbyists up there. Some are kits that you can purchase, and there's just a whole, like I said, there's a whole world of it. But the Indiana Model Engine Show, got a couple buttons from going up there. I also picked up a couple flywheels. I thought, these are castings. There was a vendor up there selling these. And I thought, if I make another model engine, it'd be nice to have a flywheel that was cast, a little heavier. I made this one, that's going to be in this video, out of just the aluminum that I had, because I didn't have anything like that. So it was kind of neat to be able to pick up some of that materials. But I was able to meet some of the club members up there. I was able to meet Aaron. It was just a really fun event, and I'm glad I was able to make the trek up there. So with all that said, let's get started with this project. I hope you enjoy. Hey everybody, welcome back. I'm Deez. This is my workshop. Today, we're going to start working on our project. I feel like I've been pushing off, not for any particular reason, just because I think it's going to take a lot of steps and I got to source a lot of materials and see how it's going to go. But I think it's time we get started on a finger engine or model engine making, that sort of thing. I've talked about it in a few other videos. The first engine that I want to attempt, and it's really just, you know, getting a flywheel to perpetually move by way of human interaction, which is your finger engine. So I was given these plans, or shared these plans to make one, and I think it's something I can tackle. It'll be a fun project. So that's what we're going to do today. And what we need to do is go shopping for materials. Now, I've got these plans. I think they're okay to share. I'm not sure. I hate to share them publicly. If they're not, maybe hit me up if you're interested in them, and I'll point you in the right direction. How about we leave it at that? But I think what we need to do is go through this, write down the parts that I need some of the materials that I need and start gathering some of the raw materials to make this product. I did already sit down. That's going to be kind of boring to go through that kind of stuff. I did sit down and I went through the finger engine plans and wrote down several of the raw materials that I think I'm going to need in order to make this. I got them written down here, right there. So I think what we'll do is go shopping over in our raw materials area and try to bring over all the parts that we're going to need in order to make this finger engine. So I think this will be a fun project. I don't know how long it'll take me. It shouldn't take too long, but we got to make all kinds of different little finicky parts and cams and, you know, flywheel and that sort of thing. It's a very simple thing, but in the end, hopefully we get a usable, perpetual sort of motion type machine that maybe we'll even install a generator and run a little light bulb on or an LED or something like that. So let's get over to the raw materials area. Let's go shopping. Let's find out if we got all the materials we need and get started with this project. First thing is we need a flywheel. It needs to be 3 to 4 inches around. The only thing aluminum that I have is this stock here, and it's 3 inch. I guess that's gonna have to be what I have. I do have a piece of steel. It's square, so we would have to somehow mount it in the lathe to where we can, you know, we can cut the corners off and make a round piece of stock. I feel like steel would be better. You know, I could cut a circle out of this, but that's going to be a lot more work. I think what we're going to do instead is use this aluminum. We'll cut a slice off of this aluminum, and this will be our flywheel. So, flywheel, done. We also need a shaft. 1/4 inch diameter, should be steel. And that's going to be probably to go through everything. Let's see what we have here. Here's our steel. That's a piece of steel that could be used. There we go. We got some 1/4 inch steel. Let's go with this. We need 1/2 inch aluminum. We need a post, so we need something that's 1/2 inch thick by 4 inches long, 1.25 inches wide. Let's see, we've got some flat stock up here. Maybe that's 1/2 inch thick. It's plenty long. And it's 2 inches wide, so that's 1.25 inches wide. So this will be for the post. Bearing insert, brass, 3/4 by 1/2 inch rod, 3/4 inch wide. I think I have some of that. There we go. So we got some 3/4 inch brass. That down there, and that's going to be for a bearing insert. The lever, that needs to be, I think it could be any material, but we want 4.25 by 3/4 and 1/4 inch thick. All right, so we got some of this. We have, that's 3/4, 1/4 inch thick, and we have more than enough to make 4.25. So we have our lever piece. Connecting rod, we need 1/4 inch thick by 3.5 inches long and 1/2 inch by 3.5 by 1/2, which I could still use that piece for that. So we got our connecting rod, or we have this steel rod that we could use. We will figure that out. Finger tab, that's going to be some brass. 1 inch by 1 inch, 250 thou or a 1/4 inch thick. We have, that's 1 inch. So we could use, it's not critical. We could use one of these pieces here. I may use this for the finger tab. That's a 1/2 inch instead of 1 inch, but honestly, but it is a 1/4 inch thick. I'm going to use this. I really don't want to cut down this piece. That's really wide. I don't think we need that. Yeah. So we're going to use this for the finger tab. So we got that piece. Crankshaft. We need a 2 inch A36 steel. 2 to 3 inches long. I don't have 2 inches. Actually, this could be 2 inches. It's 1 inch 700. It's 1 3/4 inch. We may actually use this. I'm gonna put that there for now. So we got a crankshaft. We'll figure it out. We may have to adjust that a little bit. And finally, the base is a 5x5, 3/4 inch thick. It could be wood or steel. I'm going to use a piece of wood, something like this. Yeah. This is going to be the base for the engine. All right. We got all our pieces. Now let's go back to the workbench here, kind of sort it all out and figure out what our first operation is going to be. Well, we've got our shopping list done for the most part. We can always go back and get more materials if we need them. But I think this is going to be most of the materials I'm going to need in order to produce this finger engine. There's some tricky parts, or at least for me. It seems like a pretty simple thing, but to me feels like there's some tricky parts in here to make. But that's what this project's going to be about, to learn and discover and see what else I can do with these machines. And the first thing is the flywheel and the shaft. So the flywheel is going to be made from this. It's going to be 3 inches. That's the biggest material that I have. That is round stock. And the shaft is going to be a 1/4 inch rod that will be press fit into here. So I'm going to have to get some tight tolerances and press fit the shaft into the flywheel. I'm not going to get fancy. I'm not going to put spokes or anything like that. So here is the 1/4 inch rod. I could also use this piece here and turn it down, which I might. It's 300 thou, and that would get me closer to where I'm working with. So I may actually use this one so I can turn it down, and that way when I drill and ream my hole there, I can just do some test fits. So first thing we need to do is get this mounted up in the lathe, turn the OD just so it's nice and clean, turn the face, and then have enough material to where we can cut it off in the bandsaw and then come back and clean up the other side. First thing we're going to do, make the flywheel. We're going to call that good. It's 2 thou out, but it's a rough piece anyway. And so I just need enough to clean up the edge, face this off, and get our flywheel made. We need to make this 9/16 wide. I may do just 3/4 facing this off, or turning down the OD just to clean it up. But before we do that, I think what I want to do is face this off so I have a flat side to work with, and then we'll measure in about 3/4, and then we'll clean up the OD, then we'll do our center drill and ream it for 1/4 inch. That's beautiful. It's very nice. Okay, we now have a really clean surface to work with, and now it's time to center drill and drill this out and ream it for 1/4 inch. Okay, we're finally ready to turn down the OD. Right there. Stop. Looks good. There we go. A little blemish here and here. I'm going to take a little bit more off, clean that blemish up. We may end up with a little bit of a blemish, but I can do a little bit better than that. That looks a lot better. We got that one little spot there, but we're gonna leave it. Well, we did clean up a little bit, or that was just some swarth that was in there, but regardless, I'm going to leave it at that, because what we're going to do is get our rod going, and we'll use this piece to do our test fit, because we're going to do a press fit with the rod. Well, we've got page 1 done, and that would be the flywheel and the shaft. And I think we're ready to just kind of do a little recap here before we move on to the next page, which is going to be your post and bearing insert. So what we have, you know, all this fiddly stuff takes longer than you think, you know, especially if you're recording it. But what we have, I had a first attempt at making a pin, and I ended up overshooting it, and it just fits in there. It's loose, not loosely. It might be a thou under or two, but that's not going to be a press fit. That's not going to work. So I scrapped that, made another one. Not super happy with the finish of this, but I think it will work. And that one should press fit in there nice and tight. I measured them, used my calipers, micrometer, so that I think that will do a press fit into that aluminum really well. And again, this is supposed to be 1 3/4 inches, and we are right at 1 3/4 inches. So we have our first two pieces made. That would be these two right here. We're going to scrap this pin, and yeah, we're ready to move on to the next steps. I'm not going to press these in until we get to where we're ready to start assembling, in case there's some other operation that I missed or need to work on. Like I said, the next thing we're going to do is the post and bearing insert. So we need to get our materials. We're going to need our 1/2 inch thick aluminum, and we can make our bearing insert out of this brass piece here. I think this will be our post. So we just need to cut this down and start milling it. There is an angle on the post that we can mill off. Yeah, that should be fun. Should be able to set this up with the fixture plate and mill that off of there. What we need to do is lay out this bar. We need a piece of stock that is 1/2 inch thick, 4 inches. I'll probably go 4 1/4 so we have enough material to mill off the ends. It's supposed to be 3.9 inches, but we're going to make it 4 1/4 so I can clean things up. And then the width is going to be 1 1/4 inches, 1.24 inches wide total. So we can make our markings. We'll glue this thing up. We'll go corner to corner, and we'll mount that in a fixture plate and mill that angle that we're looking for. First thing we need to do is mark our length on here. We need 4 1/4 inches. So there'll be plenty of material to work with. We only need 3.9, but like I said, I'd rather have a little extra than not enough. So that's what we're going to do right there. So we will cut that, and then after that we need this thing. This is 2 inches wide. I don't have anything narrower, so I'm going to go ahead and cut this off. We need 1.24 inches wide, so we'll cut that down. Just need to mark that. We want this piece. We have our post piece cut out. Now, hindsight, or if I had thought ahead, I would have just cut this at an angle to begin with. This piece would have been here, and I would have had a little more material here for something in the future. It really doesn't matter. It's not a whole lot of waste, but I got this little wedge here that came off of here. So this will go back in the parts area, the raw stock. This was the cut off, so we'll put that in a scrap bin. You never know. And this is the start of our tool post. So we're gonna mill the ends flat and then mill this angle. We'll figure out how to do that. I'll probably use a fixture plate. And then we need to make the bearing insert. So there's quite a bit to do with this part here. We need to put, I'm referencing this sheet here. On the bottom, we need to thread, we need to drill and tap 2 threaded holes here. That would be these guys here. There is a through hole drilled and tap actually right about this area. That'll be an 832 tap. And then we're going to drill and ream a hole for the press fit bearing up in this area here. This dimension on the total height and everything, that's flexible, right? You just need to make sure that your connecting rods and everything are the right length once you get everything done. But I think the next thing, I don't want to make the bearing insert yet. I want to go ahead and mill all of my edges flat. That way I've got some 90-degree angles to work with, and then we can work on drilling and tapping the holes that need drilled and tapped, and then drill and ream our hole for our bearing insert. I think I have a 1/2-inch reamer. Let me check. Well, this is as close as I have to a 1/2-inch reamer. Now it is a 1/2-inch reamer. It's that flex style to where you can screw this in and out and make really fine-tuned adjustments. But this is a 1/2-inch reamer, and that's what we're going to use because that's what I have. So we will be drilling this and then using the reamer to fine-tune that. Again, we could actually go oversize or undersize because we have plenty of brass material to work with. But I think the next thing to do is mount this thing up. Let's go ahead and mill off some of these edges and make this thing nice and pretty, ready for the actual drilling, tapping, and all of that. We have our fixture plate. We have about, 7 degrees of angle on this, which is roughly about what that is. It's not crucial, but we just want to clean up this angle side for the post, and that'll be the complicated part. Then I have 2 90-degree sides because I squared this up before, and we can clean up this side, the back side, the other side, and then we'll have our raw stock ready to go. So let's go ahead and get this. I've already got everything trammed in, and this isn't too low. It's not going to cut into my mill vise or anything. So let's get this side cleaned up. let's get this flat cleaned up, and then we'll have a square piece to start laying out all of our holes that we need to drill and tap and drill and ream. Get our layout done for the post. I'm just going to use the calipers, set them for the dimensions that we need so we can drill and tap if needed. I need to ream this one for my bearing insert, and then we need a couple threaded holes on the bottom for mounting the post onto the base. So, according to the diagram, it is 380 thou to the center of the hole at the top, and 323 inches, 253 and a quarter inches up from the base. So the first thing we'll do, and both of the threaded screw at the bottom as well as the hole at the top for the bearing are the same. So we have 380 thou on the caliper. So we're just going to mark this in here, and then down here. So there is our two. They're in line. We'll be able to punch that. And we need 3 1/4 from the base. It's going to be right there. So there's where the bearing insert will go. And we need to come up 625 thou from the base for this one. So we just need to punch these. So these would be lined up. This one's going to be drilled for 375 thou and tapped with an 832. The last thing we need to do is center and mark our holes for the base so that we can mount those in. So we come over 850 thou and 350 thou, and then we drill up 625 thou. 832, I need a number 29. So I went back and checked. We want to drill 375 thou deep. First thing we want to do is line this up. I'm going to use the Quill DRO to go down to my 375 thou depth of cut. Oh yeah. Okay, I think we're done with this setup. Now we have to mount this vertically and do the same with our holes on the bottom. What we want to do, one last thing I'm going to do in this particular video is to mill a flat on my shaft. I forgot to do that the other day, so let's get that in here. I'm going to use my collet in the vise on the mill. We got her in there now. Let's get this in the mill vise and tighten it down and get our flat. Well, we're going to call this part one of the N.A.M.E.S finger engine build that we're doing. And so far I'm having a lot of fun. It's a slower pace than I like to typically go with different projects, because you just need to take your time and lay everything out. But what I'm finding that's really fun is you can take liberties with some of the measurements on some of your parts. You can adjust, you can make bigger threaded holes, let's say, or you can adjust exactly where some of your parts are, but you just need to keep in mind that if you do, it's going to affect some of your other dimensions. Since I'm following the directions almost, step by step, I'm trying to keep everything to the dimensions that are drawn out. But today, in this video, we finished the first 2 pages of this, the directions here, and that's the flywheel and the shaft, and then the post and the bearing. I need to press fit some of these parts, but I'm going to wait until we do an assembly for that in case I need to go back and modify a part. For instance, I had forgotten to put the flat on the shaft for when we put the crank on there. We can use a set screw and lock that into place. But it turned out pretty nice, I think. We have our bearing. That will go in there. This will actually insert into the post. That's the bearing insert. There will be, it's a little bigger, so you're going to have a 1/4 inch gap between the crank and the post. So that will go in there. This will actually slide in there, and then this will hang out the back side, and this will also press fit on flush, so it will be about like that. So we're coming along, we're getting our components made, and everything's ready to press fit in. I think it's going to fit nice, so we're going to do pretty good there. We also have our threaded holes for the mounting portion, so I can mount this to the base. I'll probably just use some cap head screws for that. It does call to make 3 different screws, beauty more than function. I may still do that out of brass, I'm not sure. I don't have a slitting saw, so I can't really make a really nice clean slot for a screwdriver, but regardless, it's coming together. It does appear that I overshot that, I guess. I thought that was tighter than that, but I think what I'll do is use some Loctite and lock that into place, considering what this is, the finger engine. So I guess we can kind of test fit some of that now. So yeah, this will go in there. So we can do kind of a test fit here. That's going to come out like that. Of course, this will be press fit on, so it'll stick out a 1/4 inch, and then everything will spin. So it's coming together. Yep, I guess I overshot that a little bit. I thought I was closer. I was using micrometer, but still got things to learn, I guess. But I think we'll try to Loctite this in there first and use it that way, and then we could always remake these parts. But it's coming together. I know this is wordy. I get to talking. Sorry about that. We're going to close this video out here. This is part 1. We're going to keep going with this and hopefully get this thing made in 2, maybe 3 videos, but hopefully just in a couple. Thanks for watching, everybody. If you haven't subscribed, please do, and I hope you're enjoying this one.